So you have learned a lot about classes. Now, in object-oriented programming, we have another building block called an interface. Now, as the name implies, we use interfaces to define the interface or shape of an object. For example, let's say we want to represent a calendar concept. Now, you know that we have different calendar implementations. For example, we have Google Calendar, we have iCal from Apple, we have Outlook Calendar, and so on. Now, all these calendars should have some common properties and methods. So we can define all these commonalities in a base class called calendar. So we define a class called calendar, give it a constructor with one parameter, name of type string. Now here we can have methods like add event, which should take an event object, but let's not worry about that event object and just add this method here. Similarly, we can have a method called remove event that takes an event object. Now, none of these methods can have implementation because the implementation really depends on the type of calendar. For example, how we record an event in a Google Calendar is certainly different from an Outlook calendar, right? So technically, we should declare all these methods and this class as abstract. So first, we make the class abstract. Then we make these methods abstract. Here we should remove the body and just add the return type annotation. So void, and one more time, abstract, void. Good. So now that we have an abstract class, we can create concrete implementations like Google Calendar, Outlook Calendar, and so on. But before we implement any new classes, let's compile our code and see what we get in JavaScript. So here in the terminal, let's run tsc. Good. And then go to index.js. So we have the calendar class with a constructor. Now, as you can see, we don't have the abstract keyword here because abstract has no representation in JavaScript. It's purely a TypeScript concept, okay? Now, this class is totally fine, but let's see what happens if we define the same concept using an interface. So, back over here, I told you that we use an interface to describe the interface or shape of an object. So using an interface, we can say all our calendars should have a name property as well as these two methods. So for comparison, I'm going to comment out these few lines and redefine the same concept using an interface. So we start with the interface keyword, then give our interface a name like calendar. Now, people coming from C# background, they like to prefix their interface names with a capital I. Some people don't like this convention. If you're one of them, don't use it. Don't waste your time arguing which convention is better. Should we prefix our interfaces with a capital I or not? There's really no point arguing about these things. So here's the calendar interface. Now here we should describe the shape of every calendar object. So in every calendar, we want to have a name property of type string, as well as these two methods, add event, which returns void, and remove event, which returns void as well. Now, immediately you can see that our new implementation is more concise, it's shorter, we don't have all these abstract keywords, but let's recompile our code and see what we get in JavaScript. So one more time, tsc, and then we go to index.js. Look, there's nothing here, because in JavaScript, we don't have interfaces. So this interface that we define over here is purely used by the TypeScript compiler for type checking. Now, here's a question. Shall we use an abstract class or an interface? Well, it depends. In this example, our calendar class is not providing any logic or any algorithm that subclasses can reuse. We just have a bunch of method declarations. So in this case, it's better to use an interface because our code will end up being more concise and shorter, both in TypeScript and in JavaScript, right? Now, in contrast, if we had some logic here, some algorithm, some method with a few lines of code, and we wanted to share that code amongst subclasses, then we couldn't use an interface because interfaces cannot have method implementations. So if we add braces here, we get an error. We only have method declarations. We only specify the signature of our methods, okay? So here we have an interface. Now, similar to classes, here we can use inheritance. So we can define another interface called Cloud Calendar that extends the calendar interface. So it's going to inherit all these members and add something extra. So here we can have a method like sync for synchronizing to the cloud. Okay. So now we have an interface. Then what? Well, at some point, we need concrete or real calendar implementations like Google Calendar. So we define a new class like Google Calendar. Now, instead of using the extends keyword, we use the implements keyword followed by an interface like calendar. Okay? Now here we have a compilation error saying class Google Calendar incorrectly implements interface calendar. Type Google Calendar is missing the following properties from type calendar: name, add event, and remove event. So the compiler is saying, hey, you haven't implemented this interface. Now let me show you a trick. Here we put the cursor on the class name. If you're on Mac, press Command and period. If you're on Windows, press Control and period. Now here we select Implement Interface Calendar. So VS Code automatically generates this code for us. Now here we have a compilation error for name because we haven't initialized it. Now unfortunately, at the time of recording this, we cannot convert this to a constructor parameter using a shortcut. So we have to manually create that constructor with one parameter, public name of type string. And now we remove this property, okay? So now we have a class that implements the calendar interface. Tomorrow we can create another class like Outlook Calendar that implements the same interface. Now both these classes will end up having the same shape. So using an interface, we can describe the shape of an object. That's it about interfaces for now. We'll talk about them again later in the course. So that brings us to the end of this section. In the next section, we're going to talk about generics.